Hello everyone, I hope you're enjoying the workshop. I'm sorry I can't be with you today, but here's a recording of my keynote, which I'm pleased and honoured to share with you. As it's a recording, there won't be the facility for Q&A, but my email's on this opening slide and I'll show it again at the end, so please do contact me if you wish to. This is what I'm going to talk about. The title's a bit elaborate, but I wanted to convey the general topic, which is one we're working on at Northumbria University, and also to give you a run through the order of the presentation in terms of the context, what the problem is, how blockchain and smart contracts can be a potential solution, what we're doing about it, and what are the prospects for adoption, as well as the limitations and barriers. We've got a small team working on this at Northumbria, and here I'm particularly featuring parts of the work of PhD student Mahir Musawil, who some of you know already. He can't unfortunately be here present today, but I'm sure you'll hear more of him in the future. I've had an interest in construction contracts for many years, and some of the work I did was featured in the Sir Michael Latham's review of industry problems. In one of my earlier publications, the purposes of construction contracts were outlined, as well as some of the tensions concerning contracts. Should they be industry standard? And are we seeking certainty and fairness in the contracts that are produced? Because fairness requires some discretionary application of the terms, and both issues become very relevant when we try and automate the contract process. At about the same time, and this was 30 years ago, I attended a talk given by this man. It's Max Abrahamson, who wrote a standard text on engineering contracts. And Max combined a really high intellect with an air of eccentricity that made him a really engaging speaker. Two things stuck in my mind about the talk, which was basically about the language of contract. First reflected his eccentric side when he suggested that international contracts should be written in a language that nobody used in everyday life, and he pushed the idea of contracts written in Latin. But the other thing that he said illustrated his foresight. He said that one day, very soon, contracts would be executed in computer code. This was 30. Over the last 10 years, as we know, there have been several prototypes and products that do just that. Some of them are commercial and some of them more academic, but here are some examples. Kira Systems is a contract drafting tool that's been around probably for the longest period of time. We have the iContract, developed in Australia, primarily, if I remember rightly, for prompt payment down supply chains in contracts. There's the Accord project. There is Weather Ledger, which, as it says, uses weather data to accredit and implement extension of time for exceptionally adverse weather on projects. In fact, many of these references, you can read about them in the Construction Blockchain Consortium first white paper, which is on the website, which, like many of the early smart legal contract attempts, is concentrating on blockchain and construction cash flow, as it says in the subheading, inter-party payments in construction contracts. Now, construction contract problems have been the subject of many reports. I've already mentioned the Latham report. But you only have to look at some of the recent figures on the cost of contract claims and disputes, both in time and money, to see the gravity of the problem. Drilling down to the reasons for this, the 2018 Arcadis report points the finger at problems with contract administration and management, as well as poorly drafted contractual claims and a lack of understanding of what the terms of the contract are actually doing. Those of you interested in behavioral economics and transaction cost theory may be familiar with these terms that I've just put up that seek to explain what's going on in all of this. The mention of trust is particularly interesting. It's a slippery concept that crops up in a lot of reports and papers. In fact, people find great difficulty in defining it, let alone implementing it. Now, the Arcadis research blamed poor contract management for these problems. And here we've tried to categorize what goes on behind this, what lies behind it. There's a reference to the paper that explains how we came up with this categorization and what we found. The question we're really trying to tackle is, could this be solved or at least improved by the use of distributed ledgers and embedded smart contracts on the blockchain? The first problem was around the multitude of forms of construction contract. These contracts tackle similar issues in similar ways, but use different language and structure. So we chose to concentrate on the FIDIC 2017 form of contract, the so-called FIDIC Red Book. This next slide is a bit of a refresher on how the technology has developed. First of all, going back about 15 years, we have distributed ledgers, databases of immutable time-stamped records that are distributed on a layer of the internet called blockchain. And as you know, this was all designed to support the cryptocurrency Bitcoin. A little later, around 2015, the potential for the use of this technology beyond cryptocurrencies was realized, together with the fact that the system could incorporate so-called smart contracts that automatically execute transactions as well as recording them. Currently, these smart contracts require inputs that are outside the blockchain, and these are referred to as oracles. For example, the weather ledger product mentioned earlier in this talk relies on trusted off-chain weather data as its input. In other words, the process isn't entirely blockchained, isn't entirely automated, and isn't entirely trustless. I understand that future work is trying to tie the blockchain to such as the Internet of Things, and this might move us towards that situation. Returning to our problem of construction contract administration. Why might blockchain offer a solution? Well, no doubt you'll be familiar with all the characteristics of blockchain because they feature extensively in the academic literature, so I won't say too much about them. They tend to be categorized as, firstly, decentralization and disintermediation, transparency and easier auditability, consensus, immutability and verifiability, automation and programmability, and enhanced cybersecurity. The decentralization has a real potential impact in that it enables trusted collaboration without the need of the intervention of a third party, whether that is in a construction project context, the engineer, the architect, the project manager acting for the client, or indeed if a construction claim becomes a dispute, whether that third party is an arbitrator, an adjudicator, or so forth. The transparency and auditability means that the decisions, the actions within a particular contract are secure, tamper-proof, and accessible, so no party can exploit another in terms of corruption or in terms of opportunistic behavior, which I mentioned earlier. The consensus and so forth ensures that the parties understand what they are going into. Again, they reduce adverse selection, making the wrong contract drafting decisions, and again, the potential for opportunistic behavior where one party exploits the other because it knows more about the contract than the other one. Automation and programmability is at the root of the fact that smart contracts offer executable pieces of code that can do the job that currently is done manually. And of course, cybersecurity is important in terms of keeping the transaction to the people who need to know about it without others either maliciously or accidentally getting involved with the whole thing. In this next slide, we apply all of the potential described in the previous slide to the problem area that we've established, the problems with construction contract management. Again, there's a reference to the paper where we explain this more fully. Here are the potential remedies, consensus mechanisms through to decentralization and disintermediation, and here are the problems which we categorized earlier. What I've tried to do here is to link particular aspects of blockchain-based DLT and smart contracts to the individual problems that we've established. So, for instance, the problem of inaccurate documents can be improved or eliminated by these three features of blockchain-based distributed ledgers. Corruption, again, by these. Unclear roles and responsibilities, by the fact that the roles and responsibilities are encoded and self-executing. And the incompetence of the employer's agent by the fact that the automated blockchain system is decentralized and doesn't require the input of a third party for it to work. Before we look at the actual process of codifying the contract conditions that relate to contractual claims, let me show you a very simplified version of that process. Note that they contain time periods during which the actions involved are to be carried out. Failure to do so may deem a particular application to be accepted. Here are the various stages from the identification of an event that justifies the claim for time or extra expense, right through to the decision by the engineer either that the claim is justified and therefore be allowed, or that it isn't, in which case it may proceed to a dispute. Not only are the relevant terms that apply here distributed, or as I said, scattered throughout the contract, but also they contain various potential feedback loops, such as the engineer may request further details, and so forth. So, what is it we're doing in this particular project, which is designing a blockchain-based infrastructure for FIDIC 27 claims management process? I've tried to simplify this into 6 stages. First of all, finding the relevant contract conditions and how their logic worked. At this stage, it's worth mentioning some of the challenges in these first 2 stages. Here they're listed, and I'll try and explain them as quickly as possible. The first 6 in the list occur because of the peculiarities of the construction process and the relationships at play, mainly around the role of the engineer or the architect or the project manager acting as the agent of the employer in the contract. Not only does this role operate on behalf of a contracting party, the owner or employer, but there are numerous provisions where the engineer, in the case of FIDIC, has discretionary or optional powers, and that makes coding somewhat complicated. But skipping through to the last 2 items of this list, there could be a multiplicity of connected claims. In other words, they're arising from a variety of different events that are nevertheless connected in terms of the progress of the project. Similarly, there may be a multiplicity of connected claimants, because construction projects are rarely delivered by a single contractor, but also by a whole chain of subcontractors and sub-subcontractors, as well as suppliers, of course. At this stage, for pragmatic reasons and to preserve our sanity, these last 2 challenges have been ignored for the moment, but the others in the list we believe have been dealt with. There then comes the task of translating these conditions into machine readable code, and all of these 3 stages have now been completed incidentally. The next job we must do is to deploy these in a blockchain with a final API and a user interface. Of course, there's testing throughout, and Mahir has worked closely with the blockchain developer to validate his code. The most likely ultimate aim would be to deploy this in a version of the FIDIC contract that's both machine readable and human readable. And here we're fortunate to have started a good working relationship with the FIDIC blockchain working group, who will also be useful for verifying the work when it gets to that stage. Finally, we should briefly consider some of the barriers to adopting the sort of innovation that we're talking about. I'll be fairly brief because most of them are generic and you'll have read or written about them yourselves. There are the technical barriers, mainly those of energy consumption and time consumption in terms of processing time in dealing with such complex, high volume and high value transactions, as well as taking into account the two previously ignored limitations of multiple claims and multiple parties. We can be fairly hopeful that these can be solved. The legal barriers, well, they're being discussed at various sessions in this workshop. But arguably, from my mind at least, the main barriers to adoption of systems like this one that we've been working on are so-called social barriers, namely the reluctance of organizations on the one hand and the people within them to adopt change or to take the risks associated with adopting changes. With that, I'll bring my talk to a close. Here's a summary. The main point of the talk was to present a blockchain use case that is using the technology to improve the management of construction contract claims and disputes, and thereby reducing those vast amounts of time and money that is spent on them currently. We've looked at the context and how blockchain is a potential solution to the problems that arise, and finally looked at the prospects and barriers for adoption. I hope you enjoyed this talk. Here again, as promised, is my email address. Thank you very much and enjoy the rest of the workshop.